Hello everybody, it's Mr. Thompson with a video math lesson. Talking today about congruent triangles. So let's figure out what this means. We probably all know what triangles are. Three-sided, two-dimensional shape. But what does congruent mean? Well, congruent means figures that have the same size and shape. Okay, same size, same shape, basically identical. Basically the exact same triangle, one copy of another. That's what it means for two triangles to be congruent. It also means that all their parts are going to be congruent. We'll talk about that in a second again. So here's a green triangle. Here's a purple triangle, and they are congruent. I know this because I used copy and paste to create one from the other. So they're definitely congruent. They're exactly the same. All their parts are the same, as we'll see here. Okay, I'm going to label this side A on the green triangle, and what we have with congruent triangles is we have what are called corresponding parts. And this side over here, this side of this triangle, kind of matches up, you might say, with this side of this triangle. Okay, if I took the purple triangle and I actually move it over, okay, like so, then those two sides line up and you can see that they're the same. So these are sort of corresponding parts. So let's define that. We basically say that corresponding parts are the parts that are in the same position on each of two congruent figures, okay, or in this case triangles. So there's other corresponding parts. B on this one corresponds with purple B on this one. C on this one corresponds with a purple C over there on the purple one. Okay, and what we know about all these parts, let's keep talking, because there's more than just sides, there's angles. Here's this marked angle on here. Okay, that corresponds with this angle on here. Okay, on the purple one. Okay, same as the sides, and we can draw all kinds of symbols or multiple arcs, and what that tells us, this one corresponds with that one. Okay, and what these marks also mean, when you see marks like this tells you that those angles are the same. The ones that are marked the same are not only correspond, but they are congruent. They're the same measure as well. That's what those symbols mean. So what we know about corresponding parts of congruent figures is that they are all congruent. Of course, if the triangles are the same, then all the parts are going to be the same. If one's a copy of the other, then all the bits and pieces are the same as well. So if you were told that this A equals 4, and you were asked to say what this A equals, well, guess what? It's also 4. Pretty obvious. If this B is 6, then this B is also 6. Okay? If an angle here is 55, then that angle is also 55. Okay, pretty simple. Now, with triangles, we have some special rules that tell us when they are congruent. Okay, we have some what are called triangle congruence rules, often called postulates or theorems. I'm not going to get into that today. We can just call them rules. And we can use them to determine whether triangles are congruent or not. There's 4 of them that we're going to talk about today. And they are named with these abbreviations. Okay, and they're sort of shortcut names. We'll start with SSS, which is short for side, side, side. Okay, and you can probably figure out what a lot of these other ones mean, but we'll start with side, side, side. What it tells us is that if we have two triangles, okay, and one side on this triangle is congruent to another side is congruent to a side on this triangle, and another side on this triangle is congruent to another side on the other triangle, and then finally the third sides on each triangle are congruent as well, then we know that those triangles are congruent. There's no way you could make two different triangles with all the same side lengths, with 3 of the same side lengths as another triangle. It turns out they're always going to be the same. They're always going to be congruent. Okay, SAS is a different rule. And it says, it stands for side angle side. And what this is talking about is that if we have two triangles, and similar to the last one, we have one side of this one congruent to a side of that one, and then we have an angle on this one congruent to an angle on that one, and then finally another side congruent to another side. Then those triangles are congruent. We don't have to know anything else. We don't have to know anything about this side or the other angles. We just know if this is true, then we're always going to have congruent triangles. Now, an important note with this one, the A is always between the two sides. It's always side angle side, and that angle has to be between the two sets of congruent sides on each triangle. Okay, so if we knew these two sides and we knew this angle was congruent to that angle, it may or may not be a congruent triangle. Okay, in order to know, we have to know the angle between the two sides is congruent to the corresponding angle on the other one. Okay. AAS stands for angle, angle, side. So what this says is if we have two triangles, we know one angle on this triangle is congruent to an angle on the other triangle, and another angle on this triangle is congruent to another angle on that triangle, and we know the length of a side is congruent between the two triangles. Then those triangles are congruent. Now, unlike SAS, where the angle had to be a particular angle in relation to the other, in relation to those sides, in this case it's actually fine for the side to be in between the angles, whereas I have them drawn, and the way it's written, this side is sort of out to the edge, or out, sort of not between the two angles. We can swap that and make it this one between the two angles. So if we have any two angles and any side, then then the two triangles are going to be congruent. So you could call it AAS. Some places in some books will give you another rule called ASA, just to be really specific, but it's basically two angles and a side, and that's all that matters. Okay, RHS stands for right hypotenuse side. So right, referring to the fact that there's a right angle. Okay, or you could say that it is a right-angled triangle. Okay, so if we have two right-angled triangles, okay, and we know the hypotenuse as specified here in the name, the hypotenuse of one is congruent to the hypotenuse of the other, and any side is congruent on this triangle to any other side on the other, then we know those triangles will be congruent, and that's a special one just for right-angled triangles. Okay, those are our rules. Now, when we know that triangles are congruent, we need to be able to write congruence statements. Okay, so here's two triangles, and we usually identify triangles by their angles when we sort of name the angles with a capital letter. Okay, and sometimes we'll be given information. So here's some given information. AB is equal to PR. What that means is the length of AB from A to B is equal to the length from P to R. So we label those with a little notch. That means those are congruent. Okay, another given piece of information, BC equals QP. So BC equals QP. Okay, and angle B is congruent to, or the same measure as angle P. So these two angles are congruent. Okay, what that says is, well, we now have SAS. We have side angle side, congruence. These are congruent triangles. So we want to say that. We want to have a statement that these triangles are congruent, or something that says this triangle is congruent to that triangle. So we have some symbols that we use for that to make it really clear and to name the triangles. So to denote that we're talking about triangles, we have a little triangle symbol. Okay, and in order to talk about a specific triangle, we're going to use the letters, triangle ABC. So that tells us we're talking about this triangle right here. Okay, now we need something that means is congruent to, and one symbol to use for that is three lines, kind of like an equal sign with an extra little line. Another way to do it is with a squiggly on top. Okay, but sometimes they're just all straight, and that's fine. Either way, it means is congruent to Okay, and we're going to talk about another triangle, so we use the triangle symbol. And then we need to specify which triangle we're talking about. We want to talk about that one, this PQR triangle, but we need to do it in a certain order. We need to do it in the same, in sort of the corresponding order as we did for ABC. So we need to the first letter we write needs to be the letter that corresponds with the angle A on this triangle. So which one corresponds with angle A? Well, angle A is an unmarked angle. It's not B, but it's across from B, across the single dash line here from B. So we'll go to this marked angle and go across the single dash line in R. So R lines up with A. So the first letter on this congruence statement is going to be R. Okay, the next one on this one is B, and B is the marked angle, so that's pretty easy. Okay, P is the marked angle on that one, so those two are corresponding. So B and P correspond, so they go next together. And then finally, the last one is Q. This one's pretty easy. So you'll notice that they line up in order: A, B, C, R, P, Q, because R corresponds with A, P corresponds with B, and Q corresponds with C. Now, so it has to work like that. Now, there's actually a bunch of other ways we could write it, because we didn't have to do triangle ABC to begin with. We can start with C and call it the first triangle CAB, and then the second triangle would end up being differently. So all these are different ways to write the exact same thing. But it doesn't matter as long as you get one of them, and as long as those letters, you'll notice that Q always lines up with C, B always lines up with P, and A always lines up with R, right? And that's all that matters, as long as those always line up. Okay? Real quick example here before I finish off this somewhat lengthy video. Here's two triangles, okay, and we're asked to figure out, are they congruent? Well, they sure don't look congruent, but we have an angle congruent to an angle. This marked congruent. These marks tell us that they're congruent, those two angles. This line, little dash here, tells us that that side is congruent to this side, even though they don't look at all congruent. And these two dashes tell us that this side here is congruent to that side. So what we have here is SAS. We have side angle side congruence, so that tells us these two triangles are congruent. It also tells us that these drawings are pretty whack, but that's okay. They're way off. That's all right. Something that is really important to remember when looking at congruence and stuff like that, in higher level math, we don't judge by looks, okay, unless we're told to. We use the given information and markings, and by the given information, by these markings, we know that these triangles are congruent. So, for example, if we were told that this length here was 5, then we would know then that this length here is also 5, and so on and so forth. Okay? All right, that's it for today. See you next time, and good luck.